Welcome and thank you for joining me. In this lesson, we will learn about the intersections made between two planes. There are three cases that describe how two planes may be positioned against each other. Case number one is when two planes intersect at an angle between 0 and 180 degrees. In this case, the common points of intersection will lie along a straight line. This is what we call a common line of intersection. Case number two is when two planes are parallel to each other. In this case, there will be no common points of intersection. Case number three is when two planes are what we call coincident planes. In this case, any point on a plane is a common point of intersection. Algebraically speaking, the equations of these two planes will simplify to the exact same form. As you can see, when two planes intersect, they may either intersect at an infinite number of common points, like cases 1 and 3, or they may not intersect at all. It is impossible for two planes to intersect at a single point, and we can understand that by imagining how two planes extend infinitely in all directions. So when they do intersect, they intersect at an infinite number of points. Now let's take a look at a few examples that would provide an algebraic interpretation of how two planes may intersect. Example number one, we have to determine the solution to the system of these two equations, x minus y plus z equals 4 and x minus y plus z equals 5, which are the equations of two planes in scalar or Cartesian form, and discuss how these planes are related to each other. First, let's get started by writing the system of equations. We're going to call the first equation of pi 1, plane pi 1, and the second equation, the equation of plane pi 2. It is best that we number equations when we solve a system of equations. You can use numbers or you can use letters or a combination of them. Use your imagination, doesn't matter. So when we solve such systems of equations, we try to use what we call the elimination method. In this case, I will try to start off by eliminating the variable x. As you can see, x in both equations will have the exact same coefficient. So the best way to eliminate x is by subtracting the equations. And I choose to subtract the second from the first equation. So that will give us x minus x, and then minus y minus negative y, and then plus z minus z. That would be the left side, and the right side is 4 minus 5. Let's simplify. So we have x minus x, 0x, that's what we wanted. And then negative y minus negative y, oh, that's 0y. Remember, when you say minus 0y plus 0y, it won't really matter. And z minus z is 0z. The right side is 4 minus 5 equals negative 1. Now, remember that to solve for any of the variables, you will need to isolate the variable from its coefficient. And when the coefficient is 0, it means we have to divide both sides of the equation by 0. For example, if you were to solve for z, then you would have had 0z equals negative 1. And z would equal negative 1 over 0, which tells us that there is no solution for z. No solutions for z means that there are no solutions to this system of equation. And that indicates that there are no common points of intersection between two planes. And when can two planes have no common points of intersection? When they are parallel. That means that the two planes, pi 1 and pi 2, are parallel to each other. So remember that when two planes are parallel to each other, when solving the system of equations, we'll end up with having all terms all variable terms with coefficient 0, and the other side of the equation would be equal to a constant number, which makes it impossible to solve the equation, which means that there are no common points, and again, which means that the two planes are parallel. Now let's take a look at the second equation. In this case, the second example, in this case, we are given the two equations in a system and we have to solve it. Now, obviously, they represent the equations of two planes. We'll number them planes pi 1 and pi 2, and we'll number the equations with numbers 1 and 2. Now, let's examine each equation and check to see which variable would be easier to eliminate. So we have x and 4x, 2y and 8y, negative 3z, and 12z. So if I want to eliminate x, then I would have to multiply the first equation by 4, so they have the same coefficient, or negative 4 for that matter. So it doesn't really matter. So if I multiply by 4 the first equation, then I would get 4x plus 8y minus 12z equals negative 4. Remember that 4 will multiply every term on both sides of the equation. And the second equation will not change, so as is, but we will rewrite it once more. Don't forget the half braces there to indicate that they are still in the system together inside the same house. And now we will subtract. That's because the x term has the exact same coefficient. If the x term had opposite coefficients, so if we multiply by a negative, we would have had to add. So let's proceed. We have 4x minus 4x plus 8y minus 8y minus 12z, and then subtract 12z equals negative 4, subtract negative 4. So let's simplify. So we have 4x minus 4x, 0x. 8y minus 8y, 0y. Negative 12z minus negative 12z equals 0z. And negative 4 minus negative 4 is 0. Now, when you look at this equation that we just created, we have 0x, 0y, 0z, adding all together to give 0. So when you think about it, any value of x or y and z can satisfy this equation because all the terms or all the variables are multiplied by a coefficient of 0. So we're going to say that any point x, y, z will satisfy the equation. So what that means is that any point in the system will satisfy the equation, which means that there will be an infinite number of common points of intersection. And not only that, but because any point satisfies the equation means that the two planes must be coincident. So we're going to say pi 1 and pi 2 are coincident planes. So when two planes are coincident, algebraically speaking, we will see that by solving the system of equations, we will find that we get 0x, 0y, 0z equals 0. And when you look at the equations of each plane in the system, if you simplify the second equation, and you can tell here that they have a common factor of 4, which I will do now. Notice that 4x divided by 4 equals x, 8y divided by 4 equals 2y, And negative 12z divided by 4 is negative 3z. The right side, negative 4 divided by 4 is negative 1. So this is what the algebraic solution in the case when two planes are coincident looks like.